An equation is a mathematical sentence that says that two things are equal. For example, an equation could tell us that the algebraic expression 5x plus 3 equals 13. A linear equation is the simplest kind of equation and is one in which the highest power of the variable is 1. Okay? To find the value of x in this equation, we have to rearrange and isolate it by itself on one side of the equal sign. Here, for x to be by itself, we need to get rid of the 5 and the 3. So we minus 3 from one side of the equal sign to remove it, and then we repeat to the other side, so the equation can remain in balance and true. Now we're left with 5x equals 10. We have to divide 5x by 5 to be left with x, so we do this on this side. On the other side, we divide 10 by 5 to leave 2. Our solution is x equals 2. To represent the solution on a number line, we plot a solid dot on 2, and this shows there is only one value for the solution to the equation 5x plus 3 equals 13. We say it has a unique solution. Ready to try this on a more complicated equation? The strategy is the same. Get the unknown, x, on its own on one side of the equation. In this equation, one of the x terms is divided by 3, so start by multiplying both sides of the equation by 3. Then simplify to get negative 2x plus 2 equals 3 divided by 2. Next, subtract 2 from both sides of the equation. Then simplify again. Finally, divide both sides of the equation by negative 2 to get x on its own. The solution is x equals 1/4. Once you get used to it, you can write the steps in simpler form. Here's an example. You'll often need to write an equation with a variable to solve a word problem. To do this, use a letter to represent the unknown value or quantity. For example, 10 subtracted from a number is equal to 12. Let the unknown number be x. Then we can write x minus 10 equals 12 and solve the equation x equals 22. Or, for something more complex, 2 times the sum of a number and 7 is 13. Let the number equal x, then 2 times x plus 7 in brackets equals 13, and solve the equation x equals negative 1/2. For a real-world scenario, let's say James has a certain number of apples and is given another 22. He divides the apples he has between 8 people, giving each of them 14 apples. How many apples would he have started with? Let's call the number of apples he started with x. Then x and 22 added together and then divided by 8 is equal to 14. This can be written in fraction form. Then we multiply both sides by 8 to get x plus 22 equals 14 times 8. So x plus 22 is equal to 112. Subtract 22 from both sides to get x equals 112 minus 22. The answer is x is equal to 90 apples. Inequalities are very similar to equations, except you end up with a range of values for x rather than one unique solution. Here's some examples. X is less than 5. An open dot like this shows that the number it's above, 5 in this case, is not included in the solution. The line and arrowhead pointing left of 5 indicates that the solution set includes every real number smaller than 5, and this continues indefinitely. X is less than or equal to 5. The filled dot indicates that 5 is included in the solution. Once again, the line with the arrowhead to the left of 5 indicates that the solution set includes all numbers smaller than 5, and this continues indefinitely. X is greater than 7. This would mean 7 is not included in the solution set, but all numbers greater than it on the number line are. X is greater than or equal to 7. And this means 7 and all numbers greater than it on the number line are included in the solution set. Inequalities are solved in the same way as equations. For instance, if we needed to solve for x in the equality 8x is less than or equal to 32, we divide both sides by 8. The result would be x is less than or equal to 4. On a number line, we put a solid dot over 4 because 4 is included in the answer, with a line pointing left to include all the numbers smaller than 4. Now let's solve for x in the inequality 6x plus 6 is less than or equal to 36. Then show the answer on a number line. After subtracting 6 from both sides of the inequality, we get 6x is less than or equal to 30. Next, we divide both sides by 6 and get x is less than or equal to 5. On the number line, this is shown by a solid dot over 5 with a line and arrowhead extending to the left of 5. Here's an example that's slightly different. Solve for x in 5 minus 4x is less than 13. The first step is to take away the 5 from both sides, which leaves us with minus 4x is less than 8. This is where the difference comes in. We need to divide both sides of the inequality by negative 4 to get x on its own on the left-hand side. But when we multiply or divide an inequality by a negative number, the direction of the inequality sign changes. So the solution to the inequality is that x is all real numbers greater than negative 2. Word problems sometimes involve inequalities as well. For example, James and Fidel play in the same cricket team. Last Saturday, Fidel made twice as many runs as James. Together, they scored fewer than 100 runs. What is the possible number of runs that James made? The trick here is to write the correct inequality to show the situation. Let x represent the solution to the problem, which is the possible number of runs that James made. Fidel scored twice as many runs as James, so they scored x plus 2x together. And we know that their total is less than 100. So 3x is less than 100, and therefore x is less than 33.3 recurring. Runs, however, are always whole numbers. So the solution is x is less than or equal to 33.